See, I would either have to resign or make the picture with somebody else.
So now how does it go around a corner, a curve, when the outside wheel has to go further than the inside wheel? And the answer is that the wheels are flanged like this. I mean, not flanged, they're cones. This way. I think of the waves and things that are formed in the water. And when there's lots of people have dived in the pool, there's a very great choppiness of all these waves all over the water. And to think that it's possible, maybe, that in those waves is a clue as to what's happening in the pool. Just like in the swimming pool, except in 3 dimensions instead of the 2 dimensions of the pool. They're going in all directions. And we have an 1/8 of an inch black hole into which these things go. Well, to know a little bit more about it, I'd rather gather a little more of this tiny fraction of this front of light. And so I make a big telescope, which is a kind of funnel. The light that comes over this big area, 200 inches across, is very carefully organized, so it's all concentrated back so it can go through a pupil. Actually, it's better to photograph it, or nowadays to use photocells. They're better instruments. But anyway, the idea of the telescope is to focus the light that we are not yet quite clearly got the imagination to see what it is that's producing it. Quasars are very powerful sources of light and radio waves for very great distances. We can see them because they're so bright. And the exact cause of their sources is only gradually being recently understood in terms of another nutty concept of imagination, the black hole. Open the rubber band, the strings get straighter. But these strings are being bombarded on the side by these other atoms trying to shorten them.